Hello, everybody. You know, we live in a world that's just crawling with bugs, both natural and digital. And that notion of bugs has been with us in the technical world a long time. Engineers have used the term long before there were computers. In fact, even Thomas Edison referred to bugs. And in 1947, a moth got into a Mark II computer, causing a little short, and ever since then, we folks in the software and IT world have been using the word bug. I want to emphasize that because bugs have been around a long time, and in fact, we folks in the software end of the business have been busily creating bugs, finding bugs, and fixing bugs for all these years. Over the last decade or so, testing has become the dominant way of finding bugs and then, of course, setting up a situation where we can fix the bugs. A more effective way of dealing with bugs is to find them earlier. And, of course, as we've gotten more and more sophisticated with our development and our technology, we've also got more and more sophisticated with our bug creation. What I'm going to spend some time with you today is how can we reduce the cost, because it's very costly to find and fix bugs. Some data with you, and I could spend this entire seminar talking about latest studies. Let me just hit a couple of high points. 20% of all IT projects do not pay off. Percent of U.S. software projects meet performance, time, costs, and scope targets. Percent of the projects have to change their targets. Showed that the world economy loses over $500 billion, that's billion with a B, $1 billion a year, and these are failed projects, projects that never see the light of day. And the cost for projects that are constantly being patched, maintained, and are very buggy, we can't even calculate that. 10% of new project and product cost is rework. Say that a third of the software engineers out there spend their entire time fixing the things that the other two-thirds broke. And another third, 33% of all projects getting canceled. Now, these are terrible statistics. The problem is that they show the same thing. We keep developing more and more advanced technology, more and more defective software, and this costs more and more and more money. Joseph Juran, who's one of the founders of the American Quality Movement, developed a concept of what we now call cost of quality, or some folks call the cost of non-quality. And these are the total costs to produce anything, and it includes both the costs we know about and the hidden costs. And what we're going to explore today is how to get a handle on some of those costs that are very, very hard to pin down, because it's those costs that are added to the cost to produce, say, a module of software bug-free that we're interested in today. So let's look a little bit at the model and how it works. What's involved? Well, we start off, you see at the bottom of the diagram there, with what we call the cost of production. And so that would be the cost to produce a bug-free module of software. But there are additional costs added on top that we call the cost of quality, or as I said, some people today now call it the cost of non-quality. The first one is the cost of appraisal. That's the cost to find those bugs, to find the problems, the issues, etc. And of course, in our software world, that means testing of various types. Then there's a cost called the cost of prevention. And these are all the costs involved in preventing defects. And they include such things as having standards, of training people to do the job, of developing great processes that get the job done. And finally, that nasty little cost on the top, the cost of failure. And for us, failure, in fact, involves the rework we do to fix those bugs, as well as, of course, the failure of the project and all the other things you can imagine. So those three costs, the cost of appraisal, the cost of prevention, and the cost of failure, are added on top of the actual cost of production. And together we call that the cost of quality. News. I've been giving you lots of bad news. The good news is that we have known for several decades, maybe 30, 40 years, how to reduce the overall cost of quality. Start again, we've got our basic cost of production. That would be the cost to actually produce software module or the whole software application with no bugs. So we add to it first, as I said, the cost of appraisal. Now, we improve on the cost of appraisal. Well, we can leave the costs or the time spent about the same. But what we're going to do, as the arrow shows you, is we are going to shift the emphasis from the dynamic testing at the end of the life cycle up to the beginning of the life cycle. We're going to do much more robust reviews. To those a little later today. Now, if we do that, what that means is at the end of the life cycle, when we've scheduled some other testing, something very different. Today, what we run into is that since testing's done at the end of the life cycle, it's way too late, and the project may have already slipped, and so the test time gets reduced. What we're going to do is if we've shifted appraisal up front, so we're doing robust reviews of requirements, design, code, then when we get to the end of the life cycle, what we can now do is more sophisticated testing. Today we end up using our test time to do the types of exploration that find things we could have found earlier by just examining them and examining the documentation. So now I'm going to use my test time much more sophisticated way. But what I did to the cost of prevention was to increase it. So I'm going to increase the money, the time, the resources I put into prevention. What do I mean by prevention? Well, obviously, I mean, as I said, standards, defining all processes in great detail, doing a lot of training, and doing anything that helps me prevent defects from being produced in the first place. This type of activity, which also includes improvement activities that are given shorter shrift today, they're not as robust as they once